So thank you. We are going to have a look at the matrix algebra. A matrix is a rectangular array of numbers. I think we have used matrices. If we have not used them, then we must have learned them in mathematics. Both vectors and scalars are degenerate forms of matrices. In other words, they are derived from matrices. By convention, we say that an n times n matrix has n rows and m columns. Operations in matrices start from the rows to columns. We sometimes remember it using Roman Catholic, RC. Sometimes we write it as height times width. In this subsection, for us to learn this matrix algebra, we are going to use a 2 by 2 matrices. A is a 2 by 2 matrix. Take note of how the matrix is denoted. A matrix, B matrix. Then we have for instance, we have matrix addition. Look at these elements: A11, A12, A21, A22, B11, B12, B21. You start with the row, then you go to the column. Matrix addition. Matrices can be added if they are of the same size. This is achieved by summing the elements in one matrix with corresponding elements in other matrices. So, for instance, C11 is equals A11 plus B11. These two are added to create a new, eventually we add them, adding corresponding values in the matrices. If we want to scale again, we multiply each element like we did for vectors with the scaling value. In this case, denoted as S. We denoted it earlier on as lambda. Multiplication, as you're going to see in chapter 5, matrix multiplication is a cornerstone of many useful geometric transformation in computer graphics. And it is important that we be familiar with this operation. We're going to have a look at it. Matrix inverse at the identity. The identity matrix is an interesting one. Is equivalent to number 1 when multiplying scalars. So if you multiply a matrix A with the identity matrix, what you get is A. It doesn't change. The identity matrix leads to a definition of another one. Another kind of matrix we call the inverse matrix. If you multiply a matrix with its inverse, then you get the identity matrix. Matrix transposition, just like vector transposition, is simply a matter of swapping the rows and columns of a matrix. And as such, every matrix has a transpose, because you can transpose, you can change, you can swap the rows and the columns. The transpose of A is written as A transpose. So I would like you now to, considering what you have gone through this lesson, to determine the cross product of A and B, vector A and B. When you say cross product, it cannot be any other way, it has to be vector. So remember, this add line was missed, so you put the add line as you work through. You are required also to determine the inverse of the matrices given below and also give the transpose form of it. I will also upload videos to demonstrate more on how we carry out some of these matrix and matrix algebra and vector algebra. I hope that now we have had an introduction. Let me now go to the details. We have an idea of how to do addition, multiplication for matrices and algebra. I'll upload some more videos, not necessarily made by me, but available on YouTube for you really to use them to learn on how you do some of these matrix algebra. Thank you so much. This is the end of our lesson, and if you have questions, let's put them on the forum for lesson 2.